Okay, so what do we do when we have a function that is some kind of rational function, that is a fraction, that is a reciprocal of some kind? Well, we are going to use basically what we know about fractions from when we start learning them to simplify and evaluate the limits at these values. So this function I have here is 2 over x plus 3. I picked a value on the function at x equals -1, so that's going to be my a value in this case. That makes a plus h -1 plus h. And again, to find the limit, to find the slope of the tangent at this particular function, I need to set up my difference quotient, and I need to plug in these x values into the function to get the y values. So I set up my limit notation, I take this x coordinate, and I plug it into the function. So this becomes 2 over -1 plus h plus 3. Please watch where your brackets are, please watch where the denominator is, minus 2 over -1 plus 3. Again, I'm just taking my x value, plugging it into the function where x is. And don't forget, this is the part people usually forget because they get all wrapped up in their fractions. This is all still over h because we're evaluating the limit at h. That's part of my difference quotient. So once I have that all set up, I'm going to tidy my fraction up a little bit. Make sure I can actually see what the denominator is I'm working with. So -1 plus 3, this becomes h plus 2 minus 2 over, and here we can add those together. We get 2 on the bottom again, all over h. And again, we can clean that up a little bit more as well. So the limit as h approaches 0 of 2 over h plus 2 minus, and this is a 1. I'm going to write it as 1 over 1 for now. Because this is a fraction over here, I'm going to keep this as a fraction just to make it easier for me to look at. So we know with any fraction that if we're trying to simplify, we want to use what they're asking us to do. So we have to subtract these two fractions from each other, bring them together, but we can't do that unless we have a common denominator. Those rules don't change. So that's what I'm going to do here as well. So because I have a denominator of h plus 2 on this fraction, and only 1 on this fraction, I'm only going to have to change this one on the right. So I want to make that an h plus 2, which means I have to multiply the bottom and the top by h plus 2 so that I can bring these together. So this is the limit as h approaches 0 of 2 over h plus 2. And why don't we bring this together in one shot? I'm going to extend this line, subtract, and I'm going to bring these two numerators together. In a bracket though, because I find what a lot of people do is they forget about this subtraction sign. They forget that it's there, and then they don't distribute it. So we want to make sure that happens, or else your calculations are going to be off. They're going to be a little bit incorrect in terms of their signs. So now when we distribute that minus sign, we see we actually have 2 minus h minus 2 over h plus 2. And what I'm going to do in this step as well is, because I have a fraction being divided by another fraction, I'm going to change this to multiplication. I'm going to change this denominator, which is really h over 1, and I'm going to bring this up. I'm going to change it to multiplication and make it 1 over h. Also prevents us from writing too many fractions at the same time also. So in my next line, and you can do that in as many steps as you want really. In my next line here, I'm going to do the subtraction. I got 2 minus 2, which is gone, leaving me with negative h over h plus 2 times 1 over h. And now that the constant values are gone and we only have a minus h here, there's nothing stopping us from simplifying. This is linked by a multiplication sign. There's no addition between the terms that I'm trying to divide out. So I can do h divided by h and simplify this for me a little bit, which means all I'm really doing here is taking the limit as h approaches 0 of -1 over h plus 2. And again, we've reached a point where it's not a problem to evaluate at 0. There's no more undefined slope at that point. So when I go to substitute now, I can see that my slope is going to be -1 over 2. So common denominators is the way to go when you're trying to find the slope of the tangent and your function is rational function, some kind of fraction.